the three families on the basis of the mode of formation. They are igneous rocks, sedimentary rocks, and metamorphic rocks. Let's understand each one of them. So the first one is igneous rock. Now, igneous rocks are formed out of magma and lava from the interior of the earth. So magma is also called molten rock, and it is found in the mantle of the earth. If you remember this pic showing the different layers of earth, mantle is filled with magma, and when magma comes out of the surface, it cools down and becomes solid. That's how the igneous rocks are born. Now, igneous rock is also known as primary rock because it is formed from magma, so anything that is formed right from the core ingredient of the earth has to be called as primary rock. The word igneous is derived from a Latin word called ignis, which means fire. Now, mantle is filled with magma, and when magma comes out of the surface, it cools down and becomes solid. That's how igneous rocks are formed. So, mantle is in a way a fire. The process of cooling and solidification can happen both in the Earth's crust as well as on the surface of the Earth. We now know that igneous rock is formed from cooling down of magma, but you need to understand this. When magma comes out of the mantle, it can sometimes just stay under the crust. It need not get out on the surface. Sometimes magma just cools down under the crust itself. That's why during open cast mining, large chunks of igneous rocks are found. Igneous rocks are classified based on texture. When we say texture, we mean something like this. Look at the color as well as design pattern. And this texture depends upon size and arrangement of grains or other physical conditions of the materials. So if you remember while reading about physical properties of minerals, there we read that the external shape depends upon the molecular arrangement of crystals within. So rocks are these tiny soil debris packed together. And depending upon these debris, the color of the grains, overall external look will be dependent on it. If molten material is cooled slowly at greater depths, mineral grains may be very large. Sudden cooling at the surface results in small and smooth grains. Remember the third point where I said sometimes the magma cools down under the crust itself and does not really comes out on the surface. So when magma cools under the crust, it does become solid, but it does not get exposed to the external weathering agents like wind, river, and ice. Because of that, the mineral grains do not break, they are intact. And as it is, there is a huge amount of pressure under the crust, and plus temperature is not normal too. So in this situation, those igneous rocks that are found under the crust or in deep depth of the earth, they tend to be very large in size. It's like as long as the rock is under the earth's surface, the pressure and temperature doesn't let the mineral debris to split apart. It keeps them intact. The intermediate conditions of cooling would result in intermediate sizes of grains, making up igneous rocks. When you look at the rocks that comes under igneous rock, I'm talking about granite, gabbro, pegmatite, basalt, volcanic breccia. All these looks different in terms of texture and composition. And it is because of the fact that all these rocks have evolved with different conditions. I mean, some cooled early, some late, some faced more pressure, some faced less, conditions like that. After all, two products will look different only if there is a change in their process of formation. How else can they be different then? So this was about the igneous rocks. Now we move on to the second type, sedimentary rocks. The word sedimentary is derived from the Latin word sedimentum, which means settling. First of all, sedimentary rocks can be easily broken down into tiny sediments of mud and soil debris. They also have the tendency to settle down in the earth's surface easily. Rocks of the earth's surface are exposed to denudational agents and are broken up into various sizes of fragments. These denudational agents are also referred to as exogenous forces like wind, water, ice, etc. These forces over the time erodes the rock and breaks it down into small soil debris. It happens to all types of rocks, that is igneous, sedimentary, and metamorphic. Such fragments are transported by different exogenous agencies and deposited. These deposits through compaction turn into rocks. This process is called lithification. Now this process is also known as the rock cycle. I made a video on it, do check it out. Nature has such nice way of performing this rock cycle. Rocks are eroded with the help of exogenous forces like wind, air, ice into tiny little soil debris. These debris, they move from one place to another again with the help of the same exogenous forces. Now these small fragments gets deposited in the form of layers and layers one after another. This process creates pressure that is called compaction, and as it is there is good amount of heat under the crust, so it becomes all the more easier for these debris to develop into a full-fledged rock. This process is called lithification. In many sedimentary rocks, the layer of deposits retain their characteristics even after lithification. Hence, we see a number of layers of varying thickness in sedimentary rocks like sandstone, shale, etc. So, if you look at shale and sandstone, here it is. Notice there are line patterns